So I've got this problem here. We have a general triangle. We have all three sides labeled. We have 37 degrees here, and then we have A. And what we want to do is we want to find the value of A. And in this case, we could use the law of sines because A is an angle. We know the side across from it. So that's a side and an angle. We also have this angle and that side, right? So this is two sides and it's two angles, right? So we could use the law of sines. However, it's also true that we have one unknown angle A, and then we also have three sides that are known. So in this case, we could actually use either method, right? So there were three sides and one angle. So in this case, we can actually use either method to solve this problem. So I'm going to go ahead and I'm going to do it both ways. So I'm going to do the law of sines first. So we want to find A. So law of sines. Now, law of sines, we want paired angles and sides, right? So A and 2 are paired. So that's going to be sine A over 2. And then we pair that with another side angle, right? So we have 37 there. We have 1.85. So we can do sine of 37 degrees divided by 1.85. So this is our setup, right? We want to solve for A. And in this case, A is an angle, right? A is an angle. So at some point, we're going to need to remove this sine function off the angle. And so to do that, we need to apply sine inverse. But first, before we apply sine inverse, we have to isolate sine of A, right? So we need to isolate, in other words, solve for sine A, right? We have to do that before applying inverse. Before applying inverse. So in this case, it's very simple. We just have this 2 down here we don't want, multiply both sides by 2, right? So we get sine A is equal to 2 over 1.85. This is some number times sine of 37. That is also just some number. Now we have this by itself. Now we can apply the inverse. And so we apply the inverse. We do sine inverse of both sides. Sine inverse of sine of A. And on this side, we have sine inverse of 2 over 1.85 sine 37. This is something that your calculator can find, right? So we have the inverse, the angle. So this is assuming that A is less than 90 degrees. So remember, sine inverse is always going to give you an angle that's on the right half of the coordinate plane. So in this case, sine inverse is going to give us a number between 0 and 90 degrees. So we have A, and in this case, we just use our calculator here, right? So calculator, we do 2 divided by 1.85 times sine of 37. And so the inside is 0.65. And then we do sine inverse of the answer. And I have this in degrees. So we're going to get 40.59 degrees rounded. Right? So we can find the value of an angle using another paired angle inside. So we found A using law of sines. However, I mentioned we can also use the law of cosines. And so I'm going to go ahead and do the same exact problem using the law of cosines now. So law of cosines. And so remember, so the law of cosines is in green here. We have a single angle and 3 sides. And the key with the law of cosines is that the angle and the side pair, those are on opposite sides of the equation. So the side across from the angle, that's going to be squared by itself. So this would be little a squared. And then we take the 2 adjacent sides that are next to the angle, 2 sides next to the angle, those are what's squared on the other side. So 1.85 squared plus 3 squared minus 2 times 1.85 times 3 times cosine of, and this is where we need to have that angle specifically, so A. So this is our setup. And in this case, law of cosines, the setup is kind of looks more complicated. Law of sines will probably be easier here. So we have our setup. And in this case, we need to solve for A, right? So solve for A. We need to, again, isolate this cosine function before applying the inverse, right? So it's actually solve for cosine of A. So we have some math to do here, so some algebra to do here. So this is 4. I'm going to go ahead and find this here. So 1.85 squared plus 9 in that case. So that's 12.42. And we're going to subtract that. So it's going to be 4 minus 12.42. We'll use 2 decimals here. So that's equal to -2. Actually, so that's equal to negative 6 times 1.85. So 6 times 1.85. So minus 11.1 cosine of A. And finally, this is a number. We want to divide that off cosine A. And so we get 4 minus 12.42 divided by negative 11.1. So I'll use a calculator for that. But 4 minus 12.42 divided by negative 11.1. And so I have this number in memory here. It's about 0.7. So this is 0.75 is cosine of A. And then we've got cosine by itself. We want to get A by itself now. So we want to remove the cosine function, apply the inverse, right? So cosine inverse, and I'm going to keep this in the memory. So I'm just going to do cosine inverse of answer. And when we do that, we get 40 degrees, 40.6 degrees roughly is equal to A. And if we look at what our answer was for the law of sines, we can see that other than rounding errors, they are the same. So in some cases, you can use either the law of sines or the law of cosines. They will both give you the same answer. The law of cosines is actually safer to use because of technical reasons. There are cases where the law of sines will actually miss a second angle. So sine inverse will only give you a number between 0 and 90. It won't go past 90. And so because of that, sine inverse can miss a second case in some examples. So the law of cosines is a little bit safer mathematically to use than the law of sines. But in this case, it does not matter. There's only one triangle. All right.